All right, I want to talk about some of the takeaways you should have gotten from your exploration that you should have just finished. So first thing, in Desmos, you're supposed to graph this function, and you're supposed to go ahead and take a look at that, and then basically say what's weird going on there. And what you should have noticed was that your graph kind of like jumped down and had this weird sort of gap in it at x equals 1, okay? And this is actually something that we call an asymptote, okay? This is an asymptote. Basically, what's going on here at x equals 1 is that your function is getting as close to x equals 1 as it possibly can, like infinitely close, but it never actually reaches it. And it kind of freaks out when it gets to that point and goes up and down in different places, okay? And the reason why that's happening, if you look at your equation, it's actually because of the denominator, right? This x minus 1 in the denominator is causing what's called a discontinuity. And this is one kind of discontinuity, this asymptote, right? If I plug in 1, I would be dividing by 0, which we already know we cannot do, okay? So because we're causing division by 0, that's creating this asymptote, this break in my graph, basically, where it looks like it's going up and down forever there, getting as close to this line as it can without actually getting there. Now, I drew a little dashed line in here. When we do our sketches, that's actually how we're going to show asymptotes. They do not actually have a physical presence. Like if you look at your Desmos graph, there should not be like a dashed line going on in there. What's actually going on is just getting really, really close to there, but we show that dashed line to say, hey, this is like the invisible barrier that our graph is getting closer to without actually ever crossing, okay? So that is a vertical asymptote, okay? An asymptote, all right? The next one you should have seen is this little dot that should appear, this little hole. And basically what that means is that your graph's going to look like a normal graph, and there's just going to be one little spot missing from it, okay? In fact, the reason why I had this one shown here is because if you looked at it in Desmos, you wouldn't even see it, right? If you scrolled your finger over it, you would notice it then, but it's just one single point missing to the point where it's not even really seeable unless we point it out to somebody. And that's actually what we call removable discontinuity. Okay, very different than an asymptote. Asymptote, very obvious. You can see it. Oh, there's that giant gap in the middle of my graph. A removable discontinuity can barely see it. Just a little one single point missing, and besides that, it looks like a normal continuous graph. This discontinuity is going to occur for the same sort of reason when we're dividing by 0. But the thing that makes it a little bit different and makes it removable versus a vertical asymptote is that if that denominator would cancel out with a factor in the numerator, okay? This numerator factors into x plus 1 times x minus 2, and we can see that these x minus 2's would cancel and disappear. Because those factors are canceling, that is what's creating that removable discontinuity, okay? So an asymptote where you divide by 0, that doesn't cancel. Removable if it does cancel with the numerator and you're dividing by 0, that's removable discontinuity, just a single point missing. These are the two that you really need to know. These are the ones that we're going to be dealing with these rational functions, okay? Being able to identify, do I have removable discontinuity or do I have vertical asymptotes at these points? The other kind of discontinuity is one that'll show up only really with these piecewise functions. It's one I just want you to know in general, but not one we're going to see very much in this chapter, and that's called a jump discontinuity. Basically, just a big old break in your graph where it jumps from one to the other. And again, that happens with these piecewise functions where we have a rule that doesn't necessarily line up at the number that's kind of the split. So we're following this rule up till 2, and then we jump down here to the other rule, the negative 2x, and you can see those two parts don't match up. That creates this jump discontinuity, okay? So 3 kinds of discontinuities. We have vertical asymptotes, we have removable, those are the two you really need to know, and then we have the jump discontinuity that just for completion's sake we're talking about, okay? But really make sure you know, how do I get the vertical asymptote versus the removable? Again, vertical asymptote divided by 0, the denominator does not cancel out with the numerator. A removable discontinuity, that factor will cancel out. We could cancel it if we wanted to, and that's what's going to create that removable discontinuity, okay? Thank you very much for watching.